Hi everyone! In today's video I'm going to be working through question 1 of a grade 10 past paper for Maths paper 1. You'll see these are mostly factorising and simplifying algebraic expressions. I'm going to try and make my way through the rest of the paper, but let me know if there's any particular questions you want to have me to have a look at. First of all, I'd just like to say, I know when you're writing exams it's really stressful and sometimes you could just kind of freeze up. My biggest suggestion would be, from what I've seen with my students, try to write as much as you can on the paper. Okay, I know I'm a perfectionist myself and I don't want to put stuff down if I think it's silly or it's wrong, but honestly, if you have something on the paper, you're giving the teacher something to mark. And most cases, when you're feeling that panicky feeling, you actually know more than you think you do in that moment. Okay, so let's get into it. We're going to start with 1.1, where they say factorize the following expressions fully. With factorizing, we are looking usually to add some brackets into the expression. And with a question like 1.1, where there's two terms, you're generally looking to have a format where it looks something like this. So usually you are going to have a common factor on the outside and then brackets with everything that's leftovers. Okay, so let's have a look at this question. So first of all, we are going to try find out what is a common factor. So what's something we can take out of both of these terms? So immediately we can see I can take x out of the both of those. So let's take x out as our common factor. And what we'll do is we'll just do a quick scan. So there's a 4 in this one, but there's no 4 there, so we can't take that out. And there aren't any other x's in the first term. So x is our only common factor we can take out at this point. And then all we've got to do is write down what's left over. So if I've taken x out of that term, all that's left is 4. We keep the sign. And if I've taken one of the x's out of there, all that's left for the second term is x squared. Okay, that is our factorized form for now. How we can check ourselves at this point, just to make sure we're on the right track, is if we just do a quick work back, we should get the answer that we started with. Okay, so if I have x times 4, that's going to give me 4x. X times x squared is going to give me x3, and we keep that negative sign. So we can see that so far we have got the same term that we started with there. Let's just check now. A lot of times, especially when questions like this, pretty straightforward. They might be trying to hide some extra factorization in there. So if I get rid of this quick check, let's see if we can factorize any more. Okay, so we said we don't have any other common factors we can take out. But what we could use is the dots trick, so difference of two squares. So dots. So we can see here 4 is a square number, x squared is a 4 number, so we can actually factorize further using dots. So let's quickly go through that. So we keep that x in the front, and then dots, we always end up with two brackets. We say, what is the square root of 4? It's 2, we put it in both. What is the square root of x squared? It's x, we put it in both. And then we put different signs, so we put a plus in the one and a minus in the other. And that is as far as you can go in factorizing this one. So this is your final answer. Again, you could go back, multiply it all out, and check that you get back to the starting answer just to make sure you're on track. The next one we're looking at is 1.1.2. Again, we're factorizing all of these, so we want to get some sort of brackets in there. And we know for this one, it's got the form where it's got an x squared value, an x value, and then a value without any x's. So when it's in this form, what we are ideally looking for is we want to try and get two brackets like this. Okay, so that's how our factorized form is going to look. And it's a bit of a trick to get these ones. What we have to do is, how we read it is we read it backwards. And it does take some practice to get there. But what we say is, what are the factors of 54 that differ by 15? Okay, so first of all, we need to look at the factors of 54. And if you're anything like me, I have to actually have a look at these, have a think about them. So if we go 1 times 54, those are both factors. That would give me 54. We could say 2 times 27 gives me 54. Okay, so those are both factors as well, 2 times 27. And then we can keep going. We could say 3 times 18 is 54. and there might be a few more. What we're going to do, let's check these ones that we have already. So essentially, we want to find two factors that have a difference of 15. Okay, and it might take a while to pick this out, but what we can see here is 3 and 18. They differ by 15. Okay, so they have a difference of 15. So those are the numbers that we are looking for. And really simply, we put an x in both brackets, and then we put these numbers in both brackets. So we said 3 and 18. And then the only thing that's left to do is we need to figure out what is the sign of the bracket. So usually when it's like this, when it's a plus and then a minus, it means we've got different signs. And we just need to check that we get them in the right order. So let's just put them in any order right now. And what we'll do, we'll work backwards to check we've actually got the right order of those signs. Okay, so same as before, when we check factorization, we work backwards, we multiply back out. So if we multiply this one out, we're going to go x times x is x squared. X times 18 is 18x. Minus 3 times x is minus 3x. And minus 3 times 18 is negative 54. We can simplify that then, so we've got x squared, 18x, take away 3x is 15x. And we've still got that negative 54. So we can see we get to the same answer that we started with, so we know our signs are in the right place. If you got to a different answer, it probably just means that you need to just switch these signs around in here. So you would say this one would be plus, this one would be minus. That's all it means. Okay, so we've done 1.1, 1.2, now we're looking at 1.1.3. Again, factorizing, so we want brackets. What we look for is when we've got 4 terms like this, we know we're usually going to end up, we're going to have to do grouping, and we're going to have to try and get into 2 sets of brackets perhaps. Okay, so what we can do first of all, usually we try and rearrange this a little bit to see what we can take out of these. And it is a little bit strange how you organize it at first. It does take some playing around with. So what I'm going to say here is if we take a look at, let's group this minus xy plus the x, and we can group the y and the negative one. So if we rewrite this, it doesn't matter what order we write it in, as long as you keep the signs in front of the numbers as they are, or the terms as they are. So let's go. We're going to have x take away xy, and then we've still got that y in the front, and we've still got that negative 1. Okay, exactly the same expression, we just rearranged the order. Now, if we group these ones, we might be able to factorize them into that form, common factor and everything left over. So if we group it like this, what we can do is we're going to see what common factors we can take out. So from this expression here, we could take out x, because we have x in both of them. So we take x out of the bracket, and we leave whatever's left over inside. So we had, that's just going to be 1, take away y. And then for the second one, we can't really take anything out there, but we can leave it in that form. And what you can see then is these two are very similar to each other. And we have a pretty nifty trick. So with these ones, pretty similar to each other, what we can do, if we wanted to swap the order of this one, for example, we can just change the sign in front. So we have x, 1 minus y. If we change that to a minus, we can just switch those around. So it's 1 minus y like that. And now we actually have made another common factor for ourselves. Okay, because we can actually take those brackets out as a common factor, which, bear with me, I know this is gets a little bit complicated. But let's say now we're going to take out that bracket as a common factor. So if we take that out, we are going to say, take those out. 1 minus y is our common factor, and we are going to put everything that's left over. So in this one, if we take out the 1 minus y, all we are left with is x. We keep the minus sign between them. We took this one out, this bracket, so all we are left with is 1. And that is then our final result for that one after all that factorization. Next up in 1.2, we've got some simplifying problems. In most cases, like this one, when we got these brackets, they tell us to simplify it. The first thing we need to do is expand to get rid of the brackets, and then we can simplify from there. Okay, so by expanding, it means we're going to multiply everything in the first bracket by everything in the second bracket. So if we get, let's get a different color so we can see what we're doing. So if we use some yellow here, we are going to say this x here, x times x squared, and we're going to write that down. So x times x squared gives us x to the 3. We're going to go x times minus x, so we change this to negative x squared. And then we've got x times 3, which gives us 3x. And then, like I said, we've got to do everything in these brackets, so we've got to do the same thing for that too. So if we change the color again, we are going to say 2 times x squared, so that's 2x squared. 2 times negative x is negative 2x. And 2 times 3 is 6. So that is, we've expanded it, gotten rid of the brackets. The reason why we've done this is so that now we can add up terms that have the same powers of x. So we can add up all the x to the 3. In this case, we've only got 1, so that stays the same, x to the 3. We can add up all the x squared, so we've got minus x squared plus 2x squared. So that's going to go minus 1 plus 2 is going to give us positive 1x squared, or just x squared. Then we've got 3x, take away 2x. So 3 take away 2 is going to give me 1x, or just x. And then finally, I've just got that plus 6. And this is actually as far as we can simplify this. We can't add any of these terms. So that is, in fact, our answer. Next up, they want us to simplify this expression with fractions. With fractions, they are always trying to test to make sure that you know you've got to make them have the same denominators before you can do anything with them. Okay, so the first thing we want to do is find a common denominator for these. Okay, so let's just write common denominator. So that is something that we can change them both to so that we can actually do the subtraction, because they have to have the same common denominator for us to be able to actually do the subtraction. Okay, so with a question like this, when you have two expressions like this at the bottom, the common denominator is usually just the one expression times the other expression. 2 minus x. Okay, so that is what we are going to do. So to get that, we have to multiply the terms by whatever they are missing. And we are able to do this if we multiply the top and the bottom by the same term. So essentially, we are going to say this 5x plus 3, we want it to have this value in the denominator as well, that expression. So we are going to multiply the bottom by that value, by that expression. And if we multiply the bottom by that expression, we have to multiply the top by that expression. Okay, which I know we're trying to simplify, that looks even more complicated, but we are getting there. Same thing for the second term, so we've got 3, and then at the bottom, 2 take away x. So we want to have both of these terms at the bottom, so we're going to multiply by that x plus 3 term. If we do that at the bottom, we have to do it at the top as well. Okay, this is probably the hardest part, just getting these values in here. Once you have this, it's just simplifying again. So what I would say, leave the bottom for now, because we can now actually subtract these things. So if we put them all together in one, they've both got the same bottom expression. So we can say x plus 3, 2 minus x. That's for both of them, they have that. So if we then just work on the top part, we've got 5 times 2 minus x. And the other fraction, which we're just putting all together in one, is 3x plus 3. And now what you'll find is we usually end up expanding the top, simplifying, and then it should hopefully cancel with some of the bottom expressions. So let's just go ahead and simplify the top here. So if we've got 5 times 2, that's going to give us 10. 5 times negative x is going to give us negative 5x. Then we've still got that minus there. Keep in mind this minus affects the terms when you multiply in. So we're going to go minus 3 times x is negative 3x. And then minus 3 times 3 is negative 9. So that is our top then that we've expanded, and the bottom we still have that same x plus 3, 2 minus x. Let's then see if we can simplify the top at all, so we can actually sort out these numbers. So we can go 10 take away 9 is 1, so that's our new number value there. And then negative 5x, negative 3x, so that's going to give us negative 8x. And at the bottom, we're going to have those same values, we haven't done anything to them yet, to take away x. And actually, so far, I don't think we can do anything else to that, to be honest. So that is probably as simple as that one gets. Yep, that is as far as we can go in terms of simplifying. The only other step we could take then to finally finish it off is we could then say, let's multiply out the bottom fractions, the bottom expressions again. So if we just multiply those out, we're going to go x times 2. Okay, so let's just write the top again. 1 minus 8x. At the bottom, x times 2 is 2x. X times negative x is negative x squared. 3 times 2 is 6. And 3 times negative x is negative 3x. Then we can simplify those x terms. And our final answer then is going to be 1 take away 8x over negative x squared, negative x, and plus 6. And that is our final, most simplified answer for that one. Next up in 1.2.3, we have indices or exponents, as you can see, with all the little numbers at the top, the powers. When we're trying to simplify these, usually we are looking to see how we can change the bases. So for example, 25, we could rewrite 25 as 5 squared, which would mean that top number would become 5 to the negative 2x. For the second one, for 15, we could rewrite that. 15 is 3 times 5. So we could rewrite it as 3 with that exponent times 5 with that exponent. There's no problems with doing that. And then at the bottom, we've still got that 3x, can't do much with that, and the 5 to the negative x. What we can then do is they want you to use your exponent laws to simplify this. So what we do is we are going to group all the 5s and sort out all these exponents. So with the 5s, we have got 5 to the negative 2x, so we keep that up there. And then we've got 5x plus 1, so let's add that on, plus x plus 1. And at the bottom, we've got minus x. So if it's at the bottom, we put a minus. It's already got a minus, so a minus and a minus makes a plus x. For the 3, we do the same thing. So we're going to say, okay, 3 was our base. And let's sort out now what the exponents are. So for the 3, we had x plus 1, so we keep that up there. And at the bottom, we had x, so we're going to take that away because it was at the bottom. And then we can just simplify, see how far we can get from there. So if we simplify the 5 exponents, we've got x plus x, which gives us 2x. Take away 2x, so that means we don't actually have any x's at the top. And all we're left with in terms of numbers is the 1. For the 3, we are going to have x take away x, so again, our x's all cancel out, and we are left with the 1. And then 5 to the power of 1 is just 5, 3 to the power of 1 is just 3, so 5 times 3 gives us 15. And that is that one's answer. Actually really simple in the end. Okay, the final question we're going to work through in this video is 1.3. And 1.3 looks pretty scary with all the variables, but really it's testing your ability to work with what you know of quadratic equations. So what I mean by that, if we look at what they gave us to start with, so they said 3p plus q squared. That's the expression we are working with. So first thing, we need to simplify this. So let's expand it, see what we're working with. And even if you didn't know that this is what you're supposed to do first, it might help you to just play around like this in the future, see what you get. So if we expand this, what we're essentially saying is 3p plus q multiplied by itself, because it's squared. And if we multiply out, remember we multiply all the numbers by each other, so we are going to say 3p times 3p is going to give us 9p squared. 3p times q is going to give us 3pq. Again, q times 3p is 3pq. And then finally, q times q is going to give us q squared. What we can then see is we have got some other parts of this expression. So what we already have is, if I just show it in red here, this 9p squared and then the q squared part, we are told in the question 9p squared plus q squared is equal to 12. So what we can do is take those two out and just put a 12 there instead. Okay, so that is, we've already sorted that part out. Then the next part, it's a little bit different. We need a little bit more multiplying or working out. But what they have said is PQ is equal to -3. If we were to multiply both sides by 3, it doesn't matter if we do that. So let's say we multiply both sides by 3. What we are going to find is we're going to get 3PQ is equal to -9. And then it's very much in the form that we had here. Okay, sorry, that doesn't make sense. We don't need to worry about that. What we've done is we've worked out what 3PQ is. So now wherever there is a 3PQ, we can just insert that. So we have got 3PQ is equal to -9. So here we've got -9 and -9. And all we can do from there is just work out our answer. So we've got 12 take away 9 take away 9. So essentially we are doing 12 take away 18. And so we're going to get our final answer is -6.